Okay, so remember reflections. If you have negative out in front of the x squared stuff, that's going to flip it upside down. It's going to reflect it over the x-axis. Now, if it's inside here, if you had negative x squared, negative times negative turns out positive. So really, it's not going to do anything to the graph. We're going to talk about stretches and compressions. That's going to be a little tougher, but we got this. So let's try it out. So looking at this one, g of x equals negative 4x squared. Look at some of the indicators. The negative means it's going to be an upside down parabola, and that 4 means it's going to be stretched by a factor of 4. So let's see. So it's going to be, it's not shifting anywhere else, so it's going to start at 0, 0. But if you took the next x coordinate, if we were to put in positive 1, and we put that in for x here, so we have negative 4 times 1 squared. 1 squared is 1 times negative 4 is negative 4. So there's going to be our next coordinate. So 1, negative 4. Now, you know how it used to be up 1 over 1 both directions? This one goes down 4 over 1 in both directions. Down 4 over 1. Down 4, we can also go the other direction. Now, why do you think we went down 4 instead of down 1 on this one? I don't know, Mr. Plant. Where would you get a negative 4 in this equation? Oh, right there. That's where we got it. So you can take those steps and just multiply it by here. So if I was to go to the next point, remember how it was up 3 and then over 1? So if you just multiply the 3 times negative 4, then for the next point, you would go down 12 and over 1 in both directions. The next step would have been 5 and 1. So you would go down 20 and then over 1 in both directions. But we don't need to do that. We have the shape of that parabola right there. It's reflected over the x-axis, and it is stretched by a factor of 4. So I have 2 more here. 8 is going to be about the same thing. 9 is a little trickier. So here's what we're going to do. 3x squared, it doesn't get reflected. It's just stretched by a factor of 3. So the vertex is the same. Now it was up 1 over 1, but now we are going to multiply that by 3 on top. So we're going to go up 3 and over 1 for our next spot. So up 1, 2, 3, over 1, both directions. And then remember the next one would have been up 3 and over 1. So if we multiply that by 3, the next step would be up 9 and over 1. Now that's going to be way too big. Oh no, it'll fit on there. So 3 plus 9 is 12, which barely fits on the graph, and over 1. Now you can also do the mathematics for this. What? Doing mathematics in math class? That's crazy, Mr. Plan. But if you can kind of remember the rule, it saves you a lot of work. So you don't have to plug in 1 for x and solve it, or plug in 2 for x and solve that. You can, that's fine. So if you substitute in 1, 1 squared is 1 times 3 is 3. So our coordinate would be 1, 3. If we substitute in 2, 2 squared is 4 times 3 is 12. So our coordinate would be 2, 12. And then you could always just reflect those. So this one is the toughie, and I hope I don't run out of time. So this represents a horizontal compression or stretch. Who knows? Who knows? But it's not going to shift the graph at all. I'm going to run out of time, so I'll just start the next video here. But we're going to be at the same vertex, 0, 0.